How and when does steel melt? Steel melts at temperatures of 2750 degrees Fahrenheit and above, attained only in a blast furnace or when a powerful incendiary such as thermite is used. Steel or any substance that is burned will never become hotter than the temperature of the fire or heat applied to it. An open-air hydrocarbon fire reaches a maximal temperature of some 1200 degrees Fahrenheit in a dirty or uncontrolled burn, characterized by red-orange flames. Red-orange flames are what we saw on September 11th. Even the fireball caused by the plane strike was red-orange. A controlled burn falls between a dirty burn like a fireplace and a controlled environment, the blast furnace. A controlled burn employs a regulated mix of air and fuel, an example being your gas stove or the engine in your car. You can fire up your gas stove all day long, making soup, roasting a duck, or simmering a stew. Made of steel, your stove will not melt, and nor will your pots and pans. This is a kerosene heater designed for use in any ordinary house. The heater runs on jet-grade kerosene contained in this tank. Made of steel, the heater can operate all night and all day. The kerosene fumes ignite and burn inside it, never causing even the smallest part of this heater to weaken or melt. Yet we were led to believe that these tremendous buildings, framed in steel and surfaced in aluminum, totally collapsed from small scattered fires and 90 minutes of smoke. Take note of these hurtling beams, thrown laterally outward as the tower comes to earth. Would fire have the strength to eject such huge hunks of metal? Thermite. An incendiary used by the military, thermite is a compound of iron oxide and aluminum, which when ignited sustains an extreme heat reaction, creating molten iron. In just 2 seconds, thermite can reach temperatures over 4,500 degrees Fahrenheit, quite enough to liquefy steel. This is thermite melting the engine of a car. We know that open-air fires cannot burn hot enough to melt steel, but metal had melted at the base of the towers. The second product of a thermite reaction is aluminum oxide, visible as white smoke. Was thermite used in conjunction with explosives on September 11th? Watch this very bright substance pouring from the 81st floor of the South Tower. And white smoke appeared at the base of the building. Would this be aluminum oxide, the byproduct of a thermite reaction? Appendix C of the FEMA report describes sulfur residues on the World Trade Center steel. The New York Times called this the deepest mystery of all. Sulfur slightly lowers the melting point of iron, and iron oxide and iron sulfide had formed on the surface of the structural steel. Sulfur used with thermite is called thermate, producing even faster results. Let's look at what happens in the demolition industry. Taking down large structures requires preparation. Powerful explosives and heavy equipment are used in advance to weaken the foundation and bottom sections of a building before additional explosives and gravity bring the rest of it down. The words of a senior blaster.
We blow the basement, all the columns in the basement. Then we crack it up at the top to get it started. We go every other floor all the way down. Every explosive has a timer on it, that's why it's controlled. When the columns go, each floor goes down and impacts the one below and keeps going.
Here's what demolition experts use in steel-framed buildings: the linear shaped charge.
It's a chevron-shaped or V-shaped charge that you can focus at a specific target, and it's lethal. It generates around 3 million pounds per square inch pressure at a speed, depending on the explosive inside the shaped charge, in excess of 27,000 feet per second.
Besides the unfathomably powerful shaped charge, blasters have a lot of tricks.
There are over 1,000 different types of explosive. Different because they detonate at varying speeds.
With the use of delays, we can control pretty much where the debris lands. We can control vibration. We can control noise levels. Timing and delays are the key to just about everything in our business.
And what is the result?
The thing that pleases me is the fragmentation and the control. One, to take a building and break it up into millions of pieces and put it in this basement as artfully as we do it, and it works just like clockwork. So we've got it all down to a science. It gives me goosebumps to talk about it.
These core columns were discovered after the collapse. The angled cut occurs in exactly the manner that shaped charges slice through steel beams to control the way they fall. Notice the hardened, once liquid metal. Was thermite used with the shaped charge?
The job of the shaped charge is to cut steel H-beams.
The way we do this is by cutting the beam at an angle, which, through a series of beams cut at the same angle, will tend to make the building shift over and walk.
Let's look at the rubble of two 110-story buildings brought to the ground. In a 7-story crater lie nearly 2 million tons of debris. Had the basements not been blown out, where would 2 million tons have gone? Heaped on the ground, ready to slide and spill? The art of controlled demolition. The steel in dragon-like lengths and contortions spoke for itself, bent, deformed, without cracks.
I found it hard to believe that it actually bent because of the size of it and how there's no cracks in the iron. It bent without almost a single crack in it. It takes thousands of degrees to bend steel like this.
Typically you'd have buckling and tearing on the tension side, but there's no buckling at all. There's no buckling at all.
Here is the meteorite, molten iron fused with concrete.
And architects, engineers, people who work with steel, welders have just never seen the level of destruction and the level of deformation of this material in our lives.
It is true that heat expands steel. In a fire, steel members may swell and bend slightly. But this, how could these huge tangles have been created? The steel below the towers had melted at many thousands of degrees. Since metal conducts heat, were these twisted remains formed by high temperatures wicking their way through a gridwork of steel? Explosives also deform steel. As they fire, gas pushes outward. The force of the gas can easily bend a large steel column. Two kinds of debris, huge shattered columns that could break a truck, combined with matter that was near pulverized.
You have two 110-story office buildings. You don't find a desk. You don't find a chair. You don't find a telephone, a computer. The biggest piece of a telephone I found was half of the keypad, and it was about this big.